The objective function P represents the total profit earned by the company. Calculate as the sum of profit per unit for each cubicle but multiplied by their respective production levels. The first constraint is to that the total production of what types of cubibles does not exceed 100 to 1000 units per month. The second constraint limits of the demand for platinum cubibles to no more than half the demand for porcelain cubibles. This can be interpreted as either a market restriction or a production capacity limitation for platinum. For platinum cubibles, the third constraint defines the maximum production level for porcelain cubibles. It states that the number of porcelain cubibles cannot be greater than 600 units plus 3 times the number of platinum cubibles produced. This potential reflects a production capacity limitation for porcelain cubibles or a strategic dedication to maintain a certain ratio between the two types.
Okay, next question is B. Draw graph based on 1 point A. We must graph in the constraint. Firstly, we must combine production limit. We write the first constraint as y less than 1200 minus x. This represents a line with a slope negative 1 and y-intercept is 1200. Secondly, platinum demand. We write the second constraint as y less than x over 2. This represents a line with slope 1 over 2 and y-intercept is 0. Lastly, porcelain production limit. We write the third constraint as x less than 600 plus 3y. This represents a line with slope 3 and y-intercept is 200. And then the final is plot all the three lines on a graph with x on the horizontal axis and y on the vertical axis. The visible region will be the area enclosed by all three lines.
Hello everyone. So now I'm gonna explain about the graph, which is finding the optimum solution. Identify the corner points of the feasible region. These are the points where two lines intersect. Calculate the profit to each corner point using the objective functions. The corner point with the highest profit value is the optimum solution, representing the optimal production levels of porcelain and platinum crucible. For further steps, calculate the optimum production levels for X and Y. Analyze the sensitivity of the solution to changes in the constraints and objective functions coefficients. Draw conclusion and recommendation for company A, Sendirian Berhad, based on the optimizing result. So, as you see in the graph, we see this. Okay, we did a graph which is production optimizing for porcelain and platinum crucible. If you notice the graph, we mention it that is a line graph. The title for the graph is Production Optimization for Porcelain and Platinum Crucible. We start plotting the units by using the numbers, which is 0, 1200 in x-axis, same goes to y-axis. Okay, there are three lines, which is total production limit is the blue line, platinum demand limit is orange line, and porcelain production limit is green line. maximum profit point, x equals to 800, y equals to 400, profit is 2000. So two lines is intersecting. Thank you.
Hi, I want to explain question C. Let A stands for porcelain crucible, B stands for platinum crucible. Let Y equals to 1200 minus X. Based on the graph, X equals to 800. So, Y 1200 minus 800. X substitute for 800 equals to 400. So, Y we get 400. B, let Y equals to 1200 minus X. Based on the graph, we get X equals to 1050. So, Y equals to 1200 minus 1050. We get 150. It equals to Y. Model of the total cost is equal to 1.5x plus 2y. We have to calculate the total cost of A. So, we have to substitute x equals to 800, y equals to 200 in the equation, which means 1.5 times by 800 plus 2 times by 400. So, we get 2000 ringgit. The total cost of B, we have to substitute x equals to 1050 and y equals to 150. So, we get 1875 ringgit. Finally, optimum units for porcelain crucible is 800 unit and optimum units for platinum crucible is 400 unit. So, maximum profits is 2000 ringgit.